Hey everyone, in today's video, we're going to go through Organic Compounds 101. We're going to talk about alkanes, alkenes, and alkynes. First of all, we got to remember that most organic compounds have covalent bonds. That means that their chemical bonds involve the sharing of electron pairs between atoms. We actually have three different types of covalent bonding, which are going to be specifically important for the topic we're discussing today. First, we have single bonds as the ones present between two carbon atoms. We have also double bonds as the ones present between two oxygen atoms. And finally, but not less important, we have triple bonds as the ones present between a pair of nitrogen atoms. So, when talking about alkanes, it is important to know that they are saturated hydrocarbons. What does that even mean, you say? Well, it actually means that this type of chemical compound has only single bonds throughout its structure. Said that, we're going to review some common alkanes, as methane, which actually is the simplest hydrocarbon and also happens to be a powerful greenhouse gas that is flammable and is used as a fuel worldwide. Talking about its structure, we can rapidly notice that it is composed of a single carbon, and since carbon atoms have a valence of 4 and are capable of sharing 4 different electrons in their last level of energy, the carbon in methane is forming 4 single covalent bonds with 4 different hydrogen atoms H1. The next one, it's gonna be ethane, a simple alkene used for petrochemical feedstock for ethylene production and also power generation. This one is composed of 2 carbons in its main carbon chain, and as methane, each of its carbon have 4 different single covalent bonds H1. We also happen to have propane with its molecular formula C3H8 that is commonly used for space and water heating, for cooking, and as a fuel for engine application. We actually use it every day in our homes. Moving on, we have butane that has a molecular formula of C4H10, and in last we have pentane that it is a C5H12. Pentane linear structure or a skeletal structure looks like this, and each line represents a bond between a carbon with its 4 possible bonds taken by 4 different hydrogen atoms. Okay, now let's talk about the alkane's general formula that actually is CnH2n plus 2, where the N means the number of carbons that specific compound we're talking about has. This general formula is generally used to determine a compound's molecular formula, and it describes that a regular alkane has the number of hydrogens of the double of the number of carbons plus 2. So now we're going to get through some examples of the most common alkanes we have. As we have already talked about, we have methane, ethane, butane, propane, and pentane, and their respective molecular formulas. However, we also have some new examples that are hexane, heptane, octane, nonane, and decane. And to start solving them, we're going to start with example hexane, which, for its prefix X, that means 6, it's going to have an N of 6 carbons. So by replacing the N in the general formula, we will obtain C6 plus H6 multiplied by 2 plus 2, what at the end will give us hexane's molecular formula, that is C6H410. Now, you can actually stop the video if you wish and complete the following exercises by using the general formula to see if you can get them all right. Okay, now that you're back, check on your answers and compare them. I hope that you got them all right. Moving on, now we're gonna talk about the alkenes and alkynes. So, what is that main characteristic that differentiates them from alkanes? Well, instead of saturated, these ones are unsaturated hydrocarbons. That actually means that in the case of alkenes, they have double bonds throughout their carbon structure, and in the case of alkynes, they have triple bonds throughout their carbon structures. A very common and easy alkene is going to be propene, an organic compound with 3 different carbons, 2 of which are connected by a double covalent bond that looks like this one. So in this case, in order to complete the 4 electron pair rules in each carbon, we are gonna need less single bonds since the double already takes 2 electrons per each of the bonded carbons. We're gonna actually need 2 bonds with hydrogen molecules in carbon number 1. We're going to need 1 bond in carbon number 2, and the 3 full bonds on carbon number 3. And at the end, a single molecule of propene will look like this one, where all of its carbons have all their 4 electron shares and paired. Propane, on the other hand, as an alkyne, has a triple bond that contains 3 different electron pairs between 2 of its carbons. For that reason, counting from right to left, we're gonna need just another hydrogen electron on carbon number 1. We're gonna need 0 in carbon number 2, and the full 3 again in carbon number 3. So, at the end, this is how a single propene molecule will look like, with all of their carbons completed with their full 4 bonds. Talking about the general formulas, in the case of alkenes, we're gonna have the formula CnH2n, and in the case of alkynes, we're gonna have CnH2n minus 2. As in the case of the alkene butene that has 4 carbons. So, by using our general formula, we're gonna end up with the molecular formula C4H8. And if we double check with its S structure, we're going to see that the number of hydrogens also goes by 8. And by replacing the Lewis with its linear structure, we're going to end up also with this double line that represents the double bond that we have in our compound. Or as in the case of the alkyne pentyne, where its 5 carbons only make 8 different hydrogens. By using our formula, we're gonna end up with a molecular formula C5H8, and by double checking it with its structure, we're going to see that it has 8 hydrogens. In its linear structure, we have this triple line that represents also the triple bond present in our compound pentyne. Okay, now that we have covered all of the most important information, let's recap what we have gotten so far. We talked about alkanes that have only single bonds and have a general formula that goes like CnH2n plus 2. We also have alkenes that have double covalent bonding. In its general formula, it's CnH2n. And lastly, we have alkynes that are actually compounds that have triple covalent bonds, and its general formula goes like CnH2n minus 2. So guys, that's gonna be it for today. I hope it was useful, and thank you for watching Orgo Helper again. And if it's your first time, do not hesitate in dropping a like and subscribing for more organic chemistry help.